All right, intro to variable expressions and equations. So intro, the start of variables, meaning x's and y's, expressions not equal signs, equations with equal signs. Section 4. So exponential notation. Anybody know what either of those words mean? Exponential. Anybody know what that is? What about the first part of that word? What does exponent mean?
Isn't there where you write it like factors but with exponents?
Yes, exactly. So notation is just the way that you write something. You've heard of scientific notation, which we'll see again in this class, exponential notation, standard notation, stuff like that. So exponential notation is writing it with exponents. And so like what we did last class, we did, I don't know, we might call it standard notation in that case, but we did something like I'm going to erase this, but we did something like that. The way that we would write that now is 2 squared times 3. Okay, so we would use exponents. So written with exponents can be what you're writing here. With exponents. Okay, the example that I'm going to give you is 2 to the third. Okay, what is the base of that example? 2. It is the big number. Base is big, or the bottom. Okay, the lower part of that number is the base. The exponent is the 3. Exponent is the small number. Okay, up next, another word that I might use today is something called grouping symbols. What are some examples of grouping symbols? What symbols in math do you use to group stuff? Okay, let's see. No? Parentheses. Okay, parentheses is the main one that we use, but there's other ones like brackets, or something we talked about last class, absolute value lines. All those are grouping. Okay, up next, variable. Variable, we usually use the variable x, but it's something that just can change. The value can change. Okay, an algebraic expression. An example of an algebraic expression is, let's just say 3x plus 2. Okay, an expression is a grouping in math of numbers and letters. Okay, and symbols. So numbers, letters, and symbols. What about an equation? Anybody know what the difference between an expression and an equation is? Yeah.
An equation that has like it equals something.
The equal sign. So it's an expression with an equal sign, right? It has another side to it. So I'm just going to put expression with an equal sign. And remember, I will never make you write down these definitions. That's why I'm just making up the definitions as I go, because I'm not asking for exact words. I'm asking for you to understand what these words mean. Okay? All right, so evaluating expressions. These being exponential expressions. What is 5 to the third? 125. How we found that is we did 5 times 5 times 5. So 125. Okay, if you have a calculator, like the big one, it's a good thing to have and to use your calculator with. What about 1/10 squared? Anybody know what that is? 1 over 100. So we'll talk about it a lot later, that you can take that exponent and write it on each part of that, or you can just do this right now. Because exponents just mean write it that many times. So if I did 1 times 1 and 10 times 10 there, then yes, we get 1 over 100. And what about this one? 9 to the first. What's that answer? Yeah. 9. Okay, remember the exponent just says how many times you're going to write it. So if I write 9 once, that's all I get. It's 9. Okay, up next, just a reminder of order of operations. Please excuse my dear Aunt Sally is a way that some people remember it. Another way is just saying the word PEMDAS. Okay, what does the P stand for? Parentheses. Actually, I'm just going to write the symbol. Parentheses. That also can include any grouping symbol, right? So we want to do brackets as well, or absolute value lines. Another one that we didn't talk about is a square root symbol. We want to do everything that's grouped together. Okay? Up next is excuse, the E. Exponents. M. Multiplication. That means that the D stands for division. Ant. Add. And okay, one thing to remember is that these two and these two have a weird grouping. Remember, they don't have to go in that order as long as these two go before these two. So you do this first, this second. These can go either order. You just go from left to right. And these can go either order from left to right. But multiplying and division have to go before addition and subtraction. Okay? There was something that got really popular going around like Twitter and stuff this summer that was a PEMDAS thing that everybody was mixing up because the division came before the multiplication. I might pull that up and see if y'all can get it right later sometime. All right. So let's look at this first one. So what comes first? Do we have parentheses? Any parentheses? Nope. Do we have exponents? Okay. What's after exponents? Division or multiplication. From left to right. So we're going to do the division first here. So that's a 2. And then the plus 5 just comes down with it. So we've got our answer there of 2 plus 5. Okay, again, no parentheses, no exponents. Multiplication and division we do from left to right. So multiplication, we can do 30 here. Minus, we do not subtract anything, we do the division. So 30 minus 1, that gives me a 29 for my answer there. Okay, another thing that is a grouping symbol is the division line. This stuff is all grouped together, and this stuff is all grouped together. So we want to do it in that order. Okay? So first, parentheses. So that 12 plus 3 is 15. And then the 2's outside over, what is the absolute value of negative 15? 15. Okay, at this point we can cross those 15s out if you want, because that is that C over C that we talked about last class. Okay? Or we can multiply to get 30 and then cross it out. I'm going to go ahead and cross it out here and here to get me 2. Last one, exponents come first, so 3 just gets left alone, multiplied by 16. What's 3 times 16? 48. Okay, again, I know a lot of this is a reminder. You just have to go over it to make sure that it's still there, still in your head. Okay, go ahead and simplify this. Okay, so the first thing we want to do is grouping symbols. Even though they don't look like parentheses, we still want to do that first. So 3 plus 4 minus 3 is a 1. So we're going to take the absolute value of a 1 on the inside plus 2 over, we can go ahead and do that because they're already grouped together. So 6 minus 3 is 3. 3 plus 1 plus 2 over 3. So that is 6 over 3, which gives us a 2 overall. Okay, up next, algebraic expressions. So these do not have equal signs. I know that there's an equal sign here. That is because it's asking us what that turns into. It is not saying solve for this letter. Okay? So when you plug something in, this is something that's extremely important in this class. When you plug a number into a letter, if it is negative, always put it in parentheses. Always. Or if it is next to something, always put it in parentheses. Okay? So that y, when I plug this 2 in for this y, I'm not going to put it in parentheses because it's not next to something and it's not negative. But if one of these was negative numbers, or if it's next to something, we put it in parentheses. Okay? Negative or next to needs parentheses. Alright, so what we're going to do is replace those letters with those numbers. So 2 times 3 minus 2. Okay, that is 6 minus 2, which gives me 4. Okay, both of those are next to something. I know that it's written twice. That's because I couldn't get the fraction to work when I typed it up. So you can ignore this part. Alright, so when we plug those in, if I put it in parentheses, that is 9 over 4. Again, ignore this because it will actually mess you up if you do PEMDAS correctly on some of those. So look at the one that I wrote. Okay, our x was 3. It is alone, so we can just write it down. Our y is also alone, so we can write that down. Plus 2 over 2. Okay, they do have common denominators, which is great. So that is 5 over 2. Brings up a good point. I've mentioned it before. I do not like mixed numbers. Please do not turn that into a mixed number. We will not be using mixed numbers. So keep that as an improper fraction, please. Okay, last one. So we got 3 plus 4 minus our x would be 3 all over our 2 is, or our y is 2. So that is 3 plus 1 is 4 divided by 2. 2. Did I get all those answers right? Yes. Great. Man, I'm so good at that. All right. Up next, equation or expression. You've been sitting down for a while, so we're going to stand or sit, but we're going to stand on our chair if it is equation. We're going to sit back down if it's expression. Okay? So if the first one is an equation, stand on your chair. If the first one is an equation, stand on your chair. Cool. Okay, why is an equation? Very, very simple way to prove it. An equal sign. Okay, next one, number 2. Sit if you think it's an expression. Stand if you think it's an equation. Okay, number 3. Getting moving, aren't we? It's like I planned it, huh? Okay, what about number 4? Number 5. Okay, how are you going to prove this one? Number 6. If you think it's an equation, go ahead and carefully, if you would like, step up onto your desk. If not, you can stay in your chair. It's fine. Be careful. Okay?
Myers desk, he was just.
Are they the ones that are smaller that you tip forward?
I wonder.
All right, so we all know what an expression is and what an equation is. Okay, take a seat.
Oh my god.
Yeah, it's pretty nerve-wracking. Remember when I was jumping between them last class? Yeah, I was a little scared. My brother once, he's a teacher at TCA. He was walking on his desk once, and I might have told y'all, he was walking between, like he had one foot on each one, and he was looking down and ran straight into the projector, went all the way down to his back, and the projector like angled way over against the wall. He had to fix it. All right, so up next, solving equations is 2 a solution to this expression. If you remember how to do this, go ahead and try. Basically the same as what we just did. Plug it in. See if the sides equal each other. Is anyone in here allergic to peanut butter? You are? Okay.
Not that much.
Okay. You just don't eat it.
Yeah, I just don't eat it.
Okay, do the sides equal each other? Anybody know? Yes. So that means that this is a solution, right? So 6 plus 10 equals 16. We can even see it right there. So yes. Is there anything about this slide anybody thinks they need to tell me? Did I get anything wrong? Nothing? Yeah?
Expression.
Do you like Reese's?
Yes.
Okay, there we go. Okay, right there. We just talked about what expressions were, and that's not an expression, guys. So I wrote it down wrong. Watch out for Noah. Okay? All right, so that is an equation. An equation right here. So you can put that there instead, is an equation. Okay, just the last few slides on this section. Okay, these are expressions written as words. Okay, this is intro to word problems, which are terrible, I know. But if we view them just as numbers written as words like this, then it's not as hard. Okay, just pay attention to what those words mean. 6 times a number. So our expression is just 6x. Okay, up next, the product. What does product mean? Multiplying a number and 9. And we don't write x9, we write 9x. Okay, it's another reason why we use those dots instead of x's for multiplication now. Okay, the sum. What does sum mean? Adding 7 and a number. So adding 7 and a number. And normally we write x plus 7 on that, but that doesn't matter as much as the 9x. Okay? What about a number is decreased by 8? Is it 8 minus x or x minus 8?
X minus 8.
It's 8 minus x.
Okay? Well, let's see. What do we have first? What did we start with and then we took away from it? What did we decrease? We decreased the x. So we have x and we decreased that by 8. So we're going to start with x and then subtract 8 from it. Okay? Last one. 2 times a number plus 3. Okay, that comma is important because that comma means that stuff's kind of grouped together. Times a number, that's already grouped because we know we're going to multiply first anyway, and then plus 3. But if that was 2 times a number plus 7 minus 3 with a comma, then we have to do 2 times a number plus 7 in parentheses and then the minus 3 afterwards. Okay? Okay, here's the same thing with equations. The only difference is usually this word is. That word is means equals. Okay, what does quotient mean? Division. So a division answer. So the quotient of 15 and a number. So 15 and a number is 4. So that's how you could write it, and then they might ask you to solve it. Yeah.
Do you have to put 15 over x, or can we 15 with the
Division sign. You can use the division sign. You won't see that a lot in my class. I know you just saw it a little bit, but it's going to start flowing to where we won't see the division sign as much. You know, the division sign actually comes from a fraction. Look, that's a number over another number. We just don't know what those numbers are yet. So that's where that division sign comes from. Okay, up next. 3 subtracted from 12. Okay, that word from, that's what confuses some of us. What did we have first? 3 or 12? 12. So 3 subtracted from that 12 is a number. And that one's a pretty easy solve right there. Okay, up next. Triple a number is less than 8. So here's something else. I said equations. Once we said less than, it's no longer an equation. It's an inequality. It's an inequality. So triple a number is less than 48. But we'll talk about those a lot later. Okay? 4 times a number added to 17 is not equal to 21. And then last, 5 times a number is greater than or equal to an unknown number. So x. If that said is equal to another unknown number, then you would choose y there. Some people ask me about that, but right now we're only doing with one variable. Yeah.
On number 3, would you wouldn't you have to use less than or equal to, because there is a letter in there, or a variable?
No, just because of what it says. If it said less than or equal to, then you would. So right now, you just write exactly what's there. Okay? Okay, so that's the end of the first section. We take that 3 to 4 minute break. This is where you'll get a lot of your homework done, if you would like to. You can go ahead and open that up, and I'll take a look at how fast I need to go on the other one, because we took a little longer for those quizzes. I don't need to go very fast on the next one, because a lot of it you know very well. Oh, really? You did? Okay. So if you want, you can take that quiz now, real quick, if you would like to do that, or if we have time again in class. Either one. It's everything we've talked about, okay? Real numbers are all of them. But right now, we're just going to talk about regular numbers, okay? Regular numbers, meaning counting and integers, okay? So these are extremely easy problems down here. Extremely easy. I'm just going to show you on the number line, kind of get your brain wrapped around what's actually happening, just like I did last class. But I know that these are very simple problems, okay? So if we start at 2, so if I had put a dot at 2, and I go positively 3, 1, 2, 3, I'm going to end up right here at 5. So that would be my answer. So remember, the negatives tell you which direction to go. Remember, it's like absolute values. Negative 3, the absolute value is still 3, it just tells you to go to the left, okay? So here, we're at negative 1, and it says go towards the negative, or go 2 towards the negatives. 1, 2, and there's our negative 3, okay? So that means when we do mix them up and do negatives and positives, then you can follow this same track. But using the same sign, all you do is just add the numbers together and use the common sign. Okay, so 2 plus 3, And then our common sign is negative. Both of us have negatives. And 8 with a negative here. Okay? But on a number line, that can help you out if there's anything confusing. Okay, and that's what I just said. I've actually got it written down for you. Add their absolute values. Add the numbers, and then use the sign that applies to both of them. So again, 3 plus 7, 10, and they're both negatives. 21, and they're both negatives. 12, both are negatives, and 13, both are negatives. I didn't do any positives there because that's just adding two numbers together. We're pretty good at that already. Unlike signs. Unlike signs. We can go ahead and jump over this. I think we're okay with it. I'm going to do one example on the number line, but I don't expect you to draw a number line when adding two numbers together. Okay? But if we started at -2, and we go 3 in the positive direction, because it says plus 3. 1, 2, 3. That tells us where we should end up at that 1. Okay, same thing here. If we're at 4 and we go 2 in the negative direction, we end up at a positive 2. Okay, I'm going to jump to the next slide though. Okay, so adding numbers with unlike signs. There is some way that you have been taught to remember this. What is that thing that they want you to say? Yes.
Big minus little, take the sign of the
Big minus little, take the sign. I put the comma on. Okay? Take the sign of the big. I'm not going to make you close your eyes and say that over and over again. However, that is extremely helpful to remember. The big one minus the little one and take the sign of the bigger one. It's very quick, very easy. Okay? So 7 minus 3 is 4, and the bigger one has a negative. 10 minus 2 is 8, and the bigger one is positive. Going on to decimals. 0.5 minus 0.2 is 0.3, and take the sign of the bigger one. So negative. 18 minus 15 is 3, and the bigger one is negative as well. Okay, we're flying through this. Okay, another way they could say it is loss and gain. All right, just like if you remember on the homework, they talked about having a depth, and you had to use the negative integer when we were talking about depth. And the height of the mountain, you use the positive. Gain and loss. Gain is what? Positive or negative? Positive. All right, positive 2 there. Next, loss of 1. Loss is minus 1, and loss of 3. Okay? So that is just an expression right here. I know we've got this plus here. Okay? That's just a positive, but we don't usually write that at the beginning. Okay? So 2 minus 1 minus 3. How I say to do this. Okay? You've heard this when you talk about x's. I say combine like terms here. Okay? The reason I say that is because we got two things that are negatives. Let's combine those first. A negative and a negative, we're adding those together to get -4. So then that's positive 2 and -4, or positive 2 minus 4. And then we can do, actually let's do plus negative, because that's what y'all been taught. Okay? Once you have all those things combined, it's just big minus little, take the sign of the big. Once you've combined stuff. So I combine all my negatives and all my positives, and then it's just that quick subtraction with the bigger symbol over here to the side. Okay, so a loss of 5. Where did that go? Okay, a loss of 5, a gain of 8, and a loss of 2. So I'm going to combine those negatives. So I have -7, and then 8 is my positive. Now big minus little, take the sign of the big, that equals 1. Okay, here comes another one of those vocab words that actually is going to be on an exam. Okay, additive inverse, and the other way to write it is opposite. Okay, if you don't know the meaning of a word, but it gives you another option that you do understand, then use that one. If I say find the additive inverse or the opposite, You might not know what this means, but you do know what that means. So use that. It's saying those are the same. Okay? The additive inverse is whatever makes that 0. That's why it's called additive inverse. It's what do you add to make it into 0. Okay? So what is the additive inverse of 5 for number 1? What would make that into 0 if we added it? Negative 5. What would make negative 6 a 0?
Positive 6.
Okay, what would make 1/2 a 0?
Negative 1/2.
Okay, and last, what would make negative 4.5?
4.5.
Okay, so you can see that that is the same as just opposite. Okay? This word and reciprocal are going to confuse some people. Both of them are questions on tests. Okay? It says, what is the opposite of 8? That's negative 8. And then it says, what is the opposite, or what is the reciprocal of 8? And that's 1/8. Okay? Those two you get flip-flopped a lot. Opposite, if you ask anyone what opposite of, what's the opposite of light? Dark. Okay? It's always the other side. It's not flipped upside down. Okay? It's the other side of that 0. Other side of that number line. Okay? Alright, last slide. If there's a negative outside of parentheses, all that means is make the inside its opposite. Make the inside its additive inverse. Okay? It's the same thing as distributing. Okay? Distributing that negative sign. So we're going to take that negative sign and put it inside. So a negative times a negative is a positive. Okay? And remember, we can see that if there's a negative and then a negative, you take them and they turn into a positive. Okay? So that negative times that negative turn into a positive. So 2x. Okay? What's different about number 3?
It's the absolute value, so it's actually turns into negative 6.
Good. You have to solve the inside first, right? And the inside, this can't be solved. It's just grouping. This can. So what we're going to do first is take the absolute value. So 6, and then make the negative. Okay? And then last, the negative times a negative is a positive, is 7.56. Okay, we really ran through that one. Is there anything that I need to go back to? It's a lot of easy stuff you've done before. Anything that you just need to write down? Okay, awesome. So you have 20 minutes still to get all that homework. Remember that quiz, though. You can also work on retakes during this time. That's a great time to do retakes if you need to. Okay, so if you made a mistake on the quiz,